We have ACT prep number 9. Disclaimer for this series. This particular ACT practice test, the one from 2023 to 2024, that's everything in this playlist. All of these can be done with a calculator. So you have the ability to use a calculator on these sections. I think for problem number 7, I said that you couldn't use one. You can use one for all of these problems, okay? So in the figure shown below, E and G lie on AC. Anytime we have a graph or a diagram like this, it's good to figure out what exactly it's telling us. So EG lie on AC. Okay, so it just means they're on this line. This huge line, E and G are both on it. D and F lie on AB, so same thing over here on the left side. D and F are both on AB, this line here. DE, the segment, and FG, the segment, DE and FG, the segment, are parallel to BC. So both of them are parallel to BC, which means we should mark that on our graph because it's not marked, or on our diagram. We mark parallel lines by these little arrows, and since they're parallel to BC, they are also parallel to each other, okay? And the given lengths are in feet, okay? So this is 8 feet and 16 feet. What is the length of AC in feet? Okay, so AC is this line here. So this problem is talking about similar triangles. So we know triangles are similar if all of their angles have the same measure, for example. And similar triangles have the same angle measures, but they have different dimensions. So for example, let's say ADE, this triangle ADE, is similar, that's our similar sign, to triangle, let's say AFG. I'm gonna run a room, AFG. In order for that to be true, angle A has to equal angle A. Angle D here, or angle ADE, has to equal, not be similar to, equal, or be congruent to, angle AFG, or angle F, and angle E, or angle AED, has to be congruent to angle G, or angle AGF, okay? We know that is the case because we have the alternate interior angle theorem, okay? Alternate interior angle theorem. Theorem has an E. Alternate interior angle theorem, okay? It's also known as AIA theorem, THM theorem, because that's like the capital letters for all of them, right? What that means is that, let's say these lines extend forever, okay? If we have two parallel lines, then the angles here are congruent, okay? Excuse me, we actually don't need that theorem. It's a go, and this is true. The alternate interior angles are congruent, but also we have the corresponding angle theorem. And this is why it's good to go over these problems, because sometimes if you have all of the tools in your toolkit to solve these geometrical problems, you can go about them a bunch of different ways. It's like a puzzle, and you can figure out how to do that puzzle a bunch of different ways. So corresponding angles is the fastest way to do this problem. So what that means, if we have parallel lines again, the angles that correspond to the same spots are going to be equivalent or equal. So angle ADE must be congruent to angle AFG because they are in the same place. Imagine we have 4 angles here, right? Which we do. We have AD and then something over here. So like this angle D on the outside here. We have this angle on the bottom side here, on the bottom left, the angle on the top right, which is ADE, our angle that we want to be congruent. And then we have AFG right here. So the ones in the same place per se, those will be congruent because we have parallel lines and an intersecting line. Okay, so this line AB intersects it, okay? So that means these angles are congruent. The same thing applies for angle ADE and angle ABC. So, because we know that these angles are congruent to each other, we also know that these two triangles are similar. ADE, and triangle AFG. They're congruent because we can say the same thing for angle AED and angle AFG. They also must be congruent to each other because the same theorem applies, the corresponding angles theorem. I forgot to write theorem. And all that theorem is, if you want a definition for it, is corresponding angles are congruent to one another if parallel lines exist and a line intersects them. Okay? So corresponding angles are congruent to one another if parallel lines exist and a line intersects them. So we have parallel lines that exist. We have DE and BC, for example, and then an intersecting line like AC or AB. Those both exist, so then those corresponding angles must be congruent. So likewise, because AED is congruent to angle AGF by the same reasoning, they also must be congruent to angle ACB. My dog is murdering my beanbag at the moment. He's scratching it. So that's what you hear. That's what that is. All right. So because we know this angle is congruent to this angle, and this angle is congruent to this angle, we also know that angle A is congruent to itself, right? Because an angle always equals itself, right? That's another important theorem. Might not seem important, but it's an important one. Here's that definition for you. So we know, because of all that, we have three angles congruent. We must have similar triangles. So we know that triangle, oh, that's an A. Triangle ADE is similar to triangle ABC. So where does that get us? We know that's true. Where does that get us? Well, where it gets us is we can use ratios to find out what we need. We want what is the length of AC in feet. Well, we have AB equals 8 plus 7 plus 6, which is AD plus DF plus FB, which equals 21. If you ever have numbers in a row like this, like right next to each other, like 8 plus 7 plus 6, you can just add 7 3 times. It's kind of a cool trick. Because this is one higher than 7, this one lower than 7, so the average of them is 7. It's kind of a neat trick. So it's 21 for AB. And we know that this ratio of AB must be the ratio of AB to AD, the same ratio as that to AC to AE. So mathematically, AB to AD, we'll write AD on top. Write AD to AB. So AD to AB is the same thing, the ratio will equal AE to AC. Okay, because we have similar triangles, so their parts must also be similar, which is these angle sides. And therefore the ratios must be similar. So AD, we know that equals 8. AB, this is just substituting, AB, we just found equals 21. So 8 over 21 equals AE over AC. AE is 16, AC is unknown. So now we want to know, how do we get this ratio to be equal? Well, we could multiply the left side by 2 over 2, because that's just multiplying it by 1. And then we get 16 over 42 equals 16 over 42. Because 16 equals 16, we can just look right across and say, oh, AC must equal 42. So our answer is going to be 42 because we had similar triangles because of corresponding angles, and then we equated their ratios of side lengths because all similar triangles have parts that will correspond to the correct ratios. All right, our answer is D, 42.